FSPro ERC Streams. This short video will provide information about the ERC stream page in the FSPro Fire Behavior Model and will include understanding the ERC stream data, where it comes from, and weather forecast considerations. Fire spread probability, or FSPro, is a useful tool in assessing probable fire impacts in the long term. As with many models, however, quality inputs are needed to produce quality outputs. In this video, we will discuss the ERC stream page and the user selections from this page. ERC Streams is one of the required inputs before an FSPro run can be made. After you've created an FSPro run, but before you can progress to the ERC stream page, you must first complete the ERC classes page. On my screen shown here, I have opened the ERC stream page before first selecting a station and generating the ERCs from the ERC classes page. You can see I do not have any stream data, and I have a green message at the top. The message is indicating that the user must first complete the inputs on the ERC classes page. If you have this message, you must go back to the ERC classes section from the left-hand menu and complete the required inputs. See the video on FSPro ERC classes for more information about the considerations needed for those inputs. I will just quickly generate the ERC classes and select Save so that we will be able to work on the ERC stream page. You can see that after I selected Save from the ERC classes page, the ERC stream page automatically loaded and the stream data is now present. The green message at the top now tells us that the ERC classes data was saved and we should review the ERC stream data. It also says that the ERC stream data and the ERC classes data need to be synchronized, and to do this we need to make sure to save this screen before we move on to another screen. If you forget and don't save the screen, you will just need to resave the ERC classes page and then come back to the ERC stream page and save it. First, let's review the ERC stream data. The table of ERC stream data summarizes the ERC values for the station that was selected on the ERC classes page for the date selected. Let's take a quick look back at that page again. From the ERC classes page, we can see that I selected the Weser River RAWs with a date filter to narrow the data to 1990 to 2012 from the dates of April 30th to September 30th. Let's now return to the ERC stream page. The dates that the station data was narrowed to are down on the left-hand column, beginning with April 29th, one day before the filtered start date, and if we scroll to the bottom and select to view the last page, the last day's data is September 30th. So these dates correspond to the dates selected on the ERC classes page. Let's return to the page that contains the start date for this analysis, which is May 10th. The second column displays the average ERC value for the given day. So for example, for April 29th, the average ERC based on the values from 1990 to 2012 is 26.93. The next column provides the standard deviation, which is a measure of dispersion or how widely spread the values are from the mean for the average daily ERC value, again based on the selected years, in this case of 1990 to 2012. So the standard deviation for the average ERC value on April 29th is 16.64. The final column shows the current year's ERC value for the specific day. For example, the ERC value on April 29th was 33, higher than the 21-year average. You will see that once the stream data days reaches the current date, in this case May 10th, the current ERC value is -1, as are all of the days after that. That is because these days have not happened yet and the ERC value is not known. The -1 denotes that the dates are in the future. There is one quirky caveat to this point. If you are simulating a fire from a past year, you will notice that the ERC values column does have ERC values listed for the days after the analysis start date. And that is because since the simulation is in the past, the values are known because they've already happened. FSPro, however, will not take these values into account for the simulation, and it will still refer to any entered forecast days and rely on the historical climatology for all of the other days for your simulation. Remember that in FSPro, the ERC values are calculated based on the NFDRS fuel model G. If the local area calculates ERC values based on another fuel model, that's okay. Just be aware that the ERC values listed here won't match up with values calculated from a different fuel model. Do not attempt to convert the ERC G values to values from a different fuel model. FSPro is set up to run on ERC G for the entire country. Now let's discuss the forecast section on the right side of the screen. The user has the option to include forecasted ERC and wind information to fine-tune the time series to known incident conditions, but is not always needed and not required to complete an FSPro run. When forecast confidence is high, using forecasts is a practical option to dictate the first few days of a projected fire behavior, but a general rule of thumb is to use no more than 33% of the analysis period as forecast days. Additionally, only use forecast days for days into the future where there is some confidence in the forecast. FSPro is designed to utilize autocorrelated, trend-based historical weather for the area, and if the forecast is wishy-washy, you're likely better off letting FSPro produce thousands of runs utilizing the historical data so that you can see the probability of what might happen rather than dictate with a deterministic forecast what will happen. For example, if you've created a 7-day FSPro run, but you've entered 6 days of forecast weather, you aren't really letting FSPro do what it was designed to do. In this example, the first 6 days of the run, for each of the hundreds or thousands of runs you do, will be the same, because they will use the same forecast. Only 1 out of the 7 days would be left to the historical data. This type of analysis wouldn't leave you with a very good picture of the probability of what could happen, since you've dictated what will happen for 6 of the 7 days of the simulation. If you do have high confidence in a forecast for extended days, consider doing a near-term analysis rather than FSPro, as that might better capture what you are likely to experience and with the proper model. If you do decide to use a few days of forecasted data, you'll need to decide where your forecast data will come from. You can easily utilize the NDFD or National Digital Forecast data by selecting the number of days you'd like to obtain from the data drop-down box, for example, 2, and then selecting the Get NDFD Forecast Data button. The NDFD data is the forecast data for the grid location closest to the selected station from the ERC classes page. The forecast data includes the forecasted ERC, the wind speed, and the wind direction for each of the days you've selected. Keep in mind, just like short-term fire behavior, FSPro utilizes 1 wind speed and direction as well as 1 fuel condition for an entire day's worth of burning. It does not vary hourly like near-term fire behavior. If you change your mind, the data can be deleted by selecting the Delete All button to delete all of it, or delete a row at a time by selecting the Delete Row button. You can also use other forecast data, such as an incident forecast. To add forecasts outside of WFDS, select the Add Row button for each of the days you'd like to add, and hand enter the ERC, wind speed, and direction. Be sure to note that the message under the weather forecast header that reads, "In order for weather forecast entries to be valid, the first forecast date must be the same as the analysis start date. For current year's runs, this isn't usually a problem. However, for runs that you are creating for past days, for example, if you are simulating a fire from last year, you will need to make sure the date of the first forecast, month, day, and year, match the analysis start date, month, day, and year. Otherwise, you will receive an error message when you try to run the model. Also be aware that if you select to get the NDFD forecast button, it will always get the current forecast from the actual current day. Therefore, if you are simulating fires in the past, you will not want to utilize the NDFD forecast, as it will populate for current days and not pull forecasted days up from past days. After you have the weather forecast the way you want it, select Save Stream and Forecast. It's a good idea to utilize the Notes section to capture information about any forecast days used. For example, if your forecast data came from the NDFD data, but you edited the wind values to more closely match the IMET winds, you should document that in the Notes section. To do this, select Notes from the left-hand menu. Type in your comments and select Save. To review, in this video, we covered understanding the ERC stream data, where it comes from, and weather forecast considerations.